So, how are we progressing through Unit 7? Hopefully it's not too terrible. There might have been a few little details that might have challenged you a little bit, but that's good for you. So now we turn our attention to what happens when in a circle we have things that cross over, we have tangents where things that only touch once. What happens to those angle measures in that situation? So we're still dealing with circles, but now we're saying, you know what? What happens when lines start crossing through circles? Because that happens all the time. Now let's take a look. So just to kind of recap, just to review, tangent just means a line that touches a circle once. Okay, so here we have your point of tangency. AB is tangent to circle C. All right? So a secant is basically just a line with two endpoints on the circle. That's it. Okay, so this is just a secant. It just goes through the circle. That's about it. If it touches only once, it becomes a tangent. So now, here's kind of the idea that we want to talk about. All right, so if I've got two secants or chords, and they intersect on the interior of a circle, so they're on the inside, the measure of the angle is half the sum of the intercepted arcs. Okay, so let's think about this here for a minute. So let's say I've got two chords that go through the circle and they intersect right here. Okay, so I've got this situation. All right, so I got A, B, C, D, X. Okay, first off, these two are vertical. All right, so they've got to be the same. Okay, so they got to be the same. So, okay, that hasn't changed since like Unit 1, Unit 2. All right, vertical angles, they're still congruent. But what are they equal to? Well, they're equal to, and both of these are going to be the same, they're equal to arc AD plus arc BC divided by 2. So that would be the measure of angle AXD. That would also be the measure of BXC. So all I'm doing, take a look at what I'm doing. All I'm doing is adding the two arcs and dividing by 2. Okay, so I'm adding this arc and this arc and dividing by 2. That's it. Likewise, for up and down, so I've got these two right here. So if I have like arc AB plus arc CD divided by 2, that will be equal to CXD, and that will be equal to AXB. Those will both be the same. Those will both be the same. And that's kind of one of the big ideas we're talking about here. So now as we go through and take a look, let's see what we got here. You know, this is the angle I'm looking for, this X here. Well, I'm going to just take 84 plus 130 divided by 2. That's it. So that's going to be 214 divided by 2. So that angle measure is going to be 84 plus 130 is 214. So that angle measure is just going to be 107 degrees. That's it. Number 2, a little bit different look to it. This time I'm given this angle, so I need to say 97 plus x divided by 2 equals 110. So multiply both sides by 2. 97 plus x equals 220. Subtract 97, and away I go. So x is going to equal 123 degrees. So that makes sense. That's how big this arc is. Okay, that's how big that arc is, 123 degrees. 3 poses a little bit different challenge in that I'm not looking directly for the angle that's going to be, you know, the sum of those two divided by 2. I'm looking for the supplement to it. So I'm still going to do my same steps. 143 plus 75 divided by 2. That's going to give me 109. But I have to realize 109 degrees is this one, and this one. Those are both 109 degrees. So to figure out my x, I actually need to take 180 minus 9 degrees and get 71 degrees. Okay, so a little bit different twist there at the end. Again, nothing too terrible, but just kind of being aware that the two arcs are going to add up to the angle. Okay. So here, let's take a look. So I've got this is 60, this is 25, this is x. So I want to take x plus 25 divided by 2 equals 60. So multiply both sides by 2. Not divide, I want to subtract 25 there. So x should equal 95 degrees. So this should be 95 degrees. That's my answer. That's my answer. Okay, so now special situations. Secant and a tangent intersect at the point of tangency, at this point right here, where the line touches the circle once. All that happens is the angle is half of the intercepted arc. Okay? It's half of the intercepted arc. So if I have arc 1 here, this angle is equal to 1/2 of the arc. Okay? And then this one over here is going to be equal to 1/2 arc ACB. All right, so angle 2 would be equal to that. Angle 1 is going to be equal to that. So all I'm saying is, wherever, however big this arc is, the angle is going to be half of it. So if I look, I'm looking for QPR. I'm looking for this angle right here. All right, number 5, the first one. So all I'm going to do is take 148 divided by 2, and that's going to be 74 degrees. That's my answer right there. That's it. So, but now take a look. So now they want, how big is arc DEF? How big is that arc? So now we got to get a little clever. This angle down here is 64. So if the angle is 64, that means the arc out here is 128. So I need to take 64 times 2. That gives me 128. Okay, so now I'm kind of well on my way. Now I have to remember, circles are 360. So I want to take 360 minus 128. So 232, that's going to be my answer. Right there, that'll be my answer. Number 7, RQS if arc, QTS if this whole big thing is 238. What do I do? Well, again, I'm going to kind of work backwards here. 360 minus 238 will give me 122. So that means this arc is 122. So if I'm looking for this angle, I want to take 122 divided by 2 and get 61 degrees for my answer. Okay. Okay, so now don't forget, big idea, a circle has got to be 360 degrees. That's a key point in kind of what I'm working with here. So in any of these situations, if I got my angle on the outside, it's going to be half the difference. If you remember back when angles were on the inside, we would add them. Now that angles are on the outside, we're going to subtract them. So angle A is going to be equal to arc DE minus BC divided by 2. Okay, if it's angles on the outside, means subtract. That's what I'm going to do. So here, angle A would be arc DC minus arc BC divided by 2. And over here, I've got two tangents. They touch twice. They each touch once. So here, angle A is going to be arc BCD, that whole arc, minus little arc BC divided by 2. So if angle's on the outside, I'm subtracting arcs. That's what I'm trying to do here. Okay, so if I look, figure out how big L is, well, I know that they tell me this is 102, so if I take 360 minus 102, I get 5258. So that means the big one, the big arc is 258. So I want to take 258 minus 102 divided by 2. That's going to give me 156 divided by 2. And that's going to be 78 degrees. That's how big that angle is. So now 9, I'm working differently a little bit. I'm working a little backwards. They're trying to tell me, they want to find arc CD. So I want to say like, okay, well, arc CD minus 95 divided by 2 equals 56. So arc CD minus 95 is going to be equal to 112. So that means arc CD is going to be 112 plus 95. So that's going to be 207. That's how big that arc's going to be. Last, number 10, I don't think is, this one's probably the most straightforward of them all. 179 minus 71 divided by 2. So 179 minus 71 would be 108 divided by 2. So my answer should just be 54. Bam, there's my answer. There we go. There we go. Not too terrible once you realize kind of what you're doing. Once you realize circle's got to be 360, and then realize that you're subtracting each one with this situation. So if we look, they say we've got the light ray as it goes through a drop of water. The ray is refracted or bent at A, B, and C. AC is 128. XBY, this one is 84. What is this angle here? So the angle hits on the outside. So I want to take 128 minus 84 divided by 2. So that's going to be 44 divided by 2 equals 22 degrees. That's it. That's my answer. There you go. One more example. I'm not 100% sure this one's in your notes. Sometimes it is, sometimes it isn't. This one I kind of feel like was similar to what we did before. So you want 25 plus x over 2 equals 60. So 25 plus x equals 120. So x will equal 95 degrees. There's my answer. Okay, so now you go to this 7.6 work and these 7.6 quizzes. And I would look forward to your questions. And a lot of this is in the setup. Be careful of where the angle is that you're talking about. Okay, thank you.